Simplifying rational expressions. Oh my gosh. It's a fraction. We're simplifying fractions. You gotta be a pro at factoring though, because they're gonna get pretty tough. If you look at this one, we're simplifying 6x plus 12 over x plus 2. If I'm factoring, first thing I always look for is a common factor. If I look at the numerator, 6x and 12 have a 6 in common, so heck, we can factor out a 6. If I factor out a 6 here, 6 times x is 6x, and 6 times positive 2 is positive 12. Now if I write the denominator, oh my gosh, they both have an x plus 2. Now, there weren't parentheses around the x plus 2, but it's an entire group, and we need it to be exactly the same to cancel it out. So we could cancel out the x plus 2 for the x plus 2, which would just leave us with 6. Now, here's why I say that. If I had a fraction like 5 over x plus 10, people are going to be tempted to simplify the 5 and 10 because 5 goes into 10. However, 10 is grouped with the x with addition and subtraction. So it'd have to be the full group for you to be able to factor it out. Like if I had 5 over 10 times x plus 10, the 10 is factored out on the outside. There you could simplify the 5 over 10, make it 1 over 2. But not when it's grouped with addition or subtraction. It has to be an entire group or a factor on the outside for you to simplify it like that. So let's try some more. We're going to factor greatest common factors and maybe see if they have anything in common. So if you look at this 15 over 25, first of all, there's just a monomial over a monomial, one term over one term, so we could just go ahead and simplify it because there isn't any plus or minus. Now if I look at 15 and 25, I'm like, 5 goes in there. 5 goes into 15 3 times. 5 goes into 25 5 times. And then with the b's, up in the numerator, I have b to the first. In the denominator, I have b to the second. An old property is with exponents is when you're dividing, you subtract the exponents. And they always end up where there are more. So we have b to the first up top, b to the second on the bottom. There are more b's in the denominator. So that's where they're going to end up. So all we have in the numerator is the 3. In the denominator, we have the 5. And also, we're going to have 1b because we did the exponents, we subtract them. 2 minus 1 is 1. So we have 3 over 5b. Another thing I show people usually is like, let's say we had 3b, that's 3 times b, and then the denominator was 5b to the second. That means 5 times b. Maybe it's easier to see it that way, and then you could cancel out a b for a b, and then you're left with 3 up top and 5b in the denominator. However, all right, look at this second one, 12c squared. It's just one term. The denominator has 2 terms and it's got addition, so I'm going to have to factor something out. What do 3c and 6 have in common? They both have a 3 in common. So we could factor out a 3 there. If we did that, I'm going to rewrite the 12c squared up top. Denominator, we factor out a 3. 3 times c is 3c. 3 times positive 2 is positive 6. Now that we have the 3 on the outside, we could simplify it with the 12 from the numerator. How many 3's go into 12? 4. So we'll make this 3 a 1. We'll make this 12 a 4. That's all we can do. So in our numerator, we have 4c squared. Our denominator, you have 1 times c plus 2. You wouldn't write the 1 there. It's just c plus 2. Now you could write it in parentheses, or you don't need to at this point, because we're not canceling anything else out. So that would be our final answer on that one. 4m minus 2. I know that those are both even numbers. I could factor out a 2. 2 times 2m is 4m. 2 times 1 is 2. Oh my gosh. And if you look at the denominator, they both have a 2m minus 1. As a group, we can cancel out the 2m minus 1 for the 2m minus 1. The only thing that didn't cancel out is the 2. And over here, 20 plus 4t. Well, those are both divisible by 4. So if I do 4 times 5 for 20 and 4 times t, now if I look at the denominator, that's close, but just because it's close doesn't necessarily mean it's the same. If I had 6 plus 10, is that the same as 10 plus 6? Yeah, 6 plus 10 is 16, 10 plus 6 is 16. So if it's addition between them, the order doesn't matter. 5 plus t can be written as t plus 5. That is not a problem at all. Now, you can't say the same with subtraction, because 5 minus 1 is not the same as 1 minus 5. 5 minus 1 is 4. 1 minus 5 is negative 4. So we can't just flip it with subtraction, but you can with addition. That's cool. Get rid of the t plus 5s. All we have left is 4, and we're having fun. Oh, wow. Now we're multiplying factoring trinomials on this one. Always look for a greatest common factor. In the numerator, they're both even, so I can divide them both by 2. 2 times x is 2x. 2 times 6 is 12. Now the nice thing about these is usually they're going to give you something that's going to cancel out. So I bet one of my factors in the denominator is going to be x minus 6. What do I know? Not always, but usually that's the case. So if I look at the denominator, I'm looking for numbers that multiply to 6 and add up to negative 7. First of all, if they multiply to a positive number, I know they either have to both be plus or both minus. Now I need them to add up to negative 7. Is that going to be 2 positive numbers or 2 negative numbers? 2 negative numbers, x minus and x minus. If I'm thinking of my factors of 6, it's 1 times 6 or 2 times 3. Which set would add up to 7? The 1 and 6. Now, do you see anything that might cancel out? Look, they both have an x minus 6. Get rid of them. All we have left in the numerator is 2. All we have left in the denominator is x minus 1. Yeah! Yeah! I think we should try 3 more of those. Whoa! Oh, 4. Goodness gracious. All right, on A, I look at the numerator, I'm like, cool, they have a 3 in common. 3 times x is 3x, and 3 times 4 is 12. That's all we can do for the numerator. Denominator, I see it ends in minus. It has to be one of each then. X plus, x minus. They have to be 1 apart from each other. Factors of 20 that are 1 apart would be 5 and 4. To make them add up to the negative 1, it'd have to be minus the 5 and plus the 4. Do you see anything in common that we could cancel out? Yeah, they both have x plus 4. So all we have left in the numerator is 3. All we have in the denominator is x minus 5. Look at that. No problem. B, 2z, or not 2z, 2z minus 2. They have a 2 in common. So we factor out the 2. 2 times z is 2z. 2 times negative 1 is negative 2. We look at the denominator. It ends in plus. So they're both plus or they're both minus. They add up to negative 4. That means they have to both be minus. Factors of 3, the only factors of 3 are 1 and 3. Anything cancel out? Yeah, this is z minus 1, way to go. We have a 2 up top, we have a z minus 3 in the denominator. Cruising. 8a plus 16. Well, I see that those are both divisible by 8. Now, I'm going to write this one above for now because I look at the denominator and I see there's a little extra work on this one. So for now, I'm going to write the 8 up here. 8 times a is 8a. 8 times 2 is 16. I look at the denominator. There's no common factor. So remember, this is the one where we have to multiply the first and last term. 2 times 2 is 4. I need factors of 4 that add up to 5, which would be 1 and 4. So we'd say a plus 1, a plus 4. But don't forget, we have to try to divide them by the number in front there, the 2. I can't do 1 divided by 2. So the 2 just kindly moves to the front, becomes 2a plus 1. Over here, I could do 4 divided by 2. It's just 2. Cool, so we're all factored up. Now I'm going to rewrite it. My numerator, we have 8 times a plus 2. Denominator, we have 2a plus 1 times a plus 2. Now they have that a plus 2 in common. So our numerator's 8. Our denominator's 2a plus 1. Now again, someone's going to see that and they're going to be like, 8 and 2a, those are both divisible by 2. But the 2a is grouped with the 1, with addition. So it would have to be a common factor on the outside if we were going to simplify it with the 8. That was brutal. You're not going to have a lot of problems with the number in front of that n squared or a squared or x squared. All right, D. We look, ends in minus. I know that means one of each. C plus, C minus. Factors of 6 that are 1 apart would be 2 and 3. To make them add up to -1, it'd have to be minus the 3 plus the 2. There's our numerator. We look at the denominator, it ends in plus. So they're both plus or they're both minus. If they add up to positive 5, that means they're both plus. Factors of 6 that add up to 5 would be 2 and 3. Do they have anything in common to cancel out? Yeah, they both have the c plus 2. Get rid of them. C minus 3 over c plus 3. Can I cancel out the c's? Can I cancel out the 3's? No, because they're grouped. This one's grouped with a minus, this one's grouped with a plus. It has to be the exact same thing for us to be able to cancel them out like that. Whew. Oh gosh! 5x minus 15. I see that those are both divisible by 5. So if I factor out a 5 in the numerator, 5 times x is 5x, 5 times -3 is -15. I look at the denominator, those are two things that I could square root with a minus in the middle. That's a difference of squares. When you do that, it factors, you just square root each one, you put one with a plus, one with a minus. Square root of 9 is 3, square root of x squared is x. Do they have anything in common to cancel out? It's close. They both have an x minus 3-ish. But again, like I said earlier, addition, flip them as much as you want. It doesn't matter. Subtraction, that's not the case. If you ever need to flip subtraction, it's pretty easy to do. All you have to do is factor out a -1. So here's how that would look. Up top, we'll just leave it for now. Denominator, the 3 plus x. If you want, you could switch it, but that's not going to cancel out anyway. But we'll keep it putting our x's first. The second one, if you need to switch subtraction, which we do, we're going to switch it, make it x minus 3. When I say factor out a -1, all you have to do is, on the outside, just put a negative sign. That's like factoring out -1. Now we can cancel out the x minus 3's. So you have 5 over negative parentheses x plus 3. And that's fine. But typically you don't write the negatives in the denominator. So you could go ahead and just move that up top or out in front. You can make it -5 over x plus 3. That's extra gravy. If you need to flip subtraction, factor out a -1. That's what we're practicing on the next. Whoa, 4 of them again? Okay. All right, you guys must be hungry for some simplifying rational expressions. X minus 4, nothing to do there. I'm going to put it in parentheses because I'm looking at the denominator. I'm like, all right, I know something's going to cancel out here. But I do have to flip the order in the denominator to make it x minus 4. If we have to flip order with subtraction, factor out a negative sign. These will cancel. All I have left is a negative sign. What does that mean? -1. Because there's invisible 1's all over the place here. 1 over -1 is -1. All right, I see the numerator. It's 8 minus m. I look at the denominator. Again, that's a difference of squares. I can square root both of those. Square root them, put one with plus, one with a minus. Square root of m squared is m. Square root of 64 is 8. So it factors to m plus 8 times m minus 8. I see the numerator's 8 minus m. I need to make it m minus 8. Easy fix. Factor out a negative 1. If it helps, write the negative 1. Otherwise, just put the negative out there. Now we can cancel out the m minus 8. We're left with negative 1 over m plus 8. Wow, unbelievable. Look at our denominator here, because that's going to be the harder one to factor. It ends in minus, so I know that's one of each. Factors of 8 could be 1 and 8 or 4 and 2. I need them to be 2 apart, which would be the 4 and 2. To make them add up to plus 2, it'd have to be positive 4, negative 2. I look at the numerator and I'm like, all right, I see that 4 goes into both of those. So if I factor out a 4, I'm left with 2 minus r. Very similar to r minus 2. But we do have to flip the order. So we're going to factor out a negative 1. Just make the 4 on the outside negative 4. Handled. Our denominator, we have the r plus 4 and the r minus 2. And now we're able to cancel out the r minus 2's. So we have negative 4 over r plus 4. That one was pretty tricky. I'm not going to lie. Look at our numerator here on D. They're both divisible by 2. So we have 2 times c squared minus 1. The denominator, they're both divisible by 3. 3 times 1 minus c squared. Very similar to c squared minus 1. We're going to have to flip the order. So to do that, we just factor out a negative 1. We'll just put the negative sign in front of the 3. So now it'll be negative 3 c squared minus 1. Now, you could factor c squared minus 1. That would be c plus 1 times c minus 1. However, at this point, they're already going to cancel each other out because they're exactly the same. So we'll just cancel them out. So we have 2 over negative 3. Again, just move your negative either up front or out in the middle. Make it negative 2/3. That was brutal. Just brutal. And that's it. We're going to end on that. Wow. Wow.